Now let's answer a problem about the circle in analytic geometry. What is the equation of the circle passing through the point 6, 2 and tangent to the line x minus 4y minus 15 equals 0 at a given point of tangent C3, negative 3? So the blue line is your line x minus 4y minus 15 equals 0. The point plotted 3, negative 3 is where the tangent and the line will intersect, the point of tangency. It's also given that the circle will pass through this point, the point 6, 2. Now what is important to know about circle is that if you connect any chord on the circle, like connecting 2 points on the circle, the perpendicular bisector of this chord will contain the center. So all you need to do is to get this bisector, the equation of this perpendicular bisector. And of course, it will pass through the midpoint of the segment connecting 6, 2 and 3, negative 3. So what's the midpoint? The midpoint would be 9/2 and negative 1/2. Now the slope of this segment connecting 6, 2 and 3, negative 3 is 2 minus negative 3, that's 5. 6 minus 3, 3, so that's 5/3. Therefore, the slope of your bisector, your perpendicular bisector, is negative 3/5. Thus, the equation would be 3x plus 5y is equal to, substitute the given 0.9/2 to x, negative 1/2 to y, we get 27/2 minus 5/2. That would be 22/2 or 11. Now this is the equation of this red line, the perpendicular bisector. Now let's use the other clue in the problem. It says the circle is tangent to this line at the given point. So if you have a point of tangency and the line, again the perpendicular to this will contain the center. So all we need to do is get the equation of the line perpendicular to this passing through the given point of tangency. So the equation would be 4x plus y is equal to 3 times 4 is 12 minus 3, that's 9. So all we need to do is to solve this system and we will get the exact coordinates of the center. So solving the system, multiplying this by 5. So you get 20x plus 5y equals 45. Then copying the other bisector, which is 3x plus 5y is 11, and subtracting. So we get 17x. 5y minus 5y will cancel out. 45 minus 11 is 34. Therefore, x is equal to 2. And if x is 2, then we can get y. 4 times 2, we use this. 4 times 2 is 8. Plus y is 9. Therefore, y is 1. So the exact coordinates of the center is 2, 1. Now, how do we get the radius? Of course, we know 2, 1. And any point, you can use 6, 2. You can use 3, negative 3, and simply use your distance formula. The radius would be 2 minus 1, squared is 1. 6 minus 2 is 4, squared is 16. So the radius is square root of 70. Now let's answer some problem next time. Good day. Welcome back. Now let's answer another problem about the circle. A circle has its center on the line 3x minus 2y minus 22 equals 0. I have it graphed and plotted. It's the blue line. And the circle is tangent to the y-axis at the point 0, 1. The red point is obviously the point 0, 1. Now, if the y-axis is a tangent line, is a tangent to the curve, then at that point 0, 1, then it only means that the perpendicular passing through this will also contain the center. So now we are very sure that the y-coordinate of the center HK, your center is HK, it's now sure that the y-coordinate is 1 because it's on the red line. Now if the center of the circle will also lie on the given line 3x minus 2y minus minus 22 equals 0, and therefore this equation can be written as 3h minus 2k minus 22 equals 0. Since we have the value of k, which is 1, this will become 3h minus 2 minus 22 equals 0. So this is 3h minus 24, or 3h equals 24, then h is 8. So the exact coordinates of the center are 8 and 1. So if the center is 8, 1, there, and this is the y-axis, then obviously the radius is 8. The standard form, the circle would be x minus 8 squared is y minus 1 squared is 64. That's it. So easy. Good.